What if we're not the first? Imagine, buried beneath layers of rock and time, the faint, eroded footprints of a civilization that rose and fell millions of years before humans ever walked the earth. No pyramids, no ruins, no surviving tools, just whispers in the geological record. This is the chilling, fascinating question at the heart of the Silurian hypothesis. Proposed by a NASA scientist and a climatologist, it asks whether it's possible that an advanced industrial civilization once existed on Earth long before us, but left behind so little evidence that we may never know for sure. It's not about dinosaurs building cities or science fiction fantasies, but rather a serious scientific thought experiment. If such a civilization had existed, what traces, if any, could survive the relentless passage of deep time? Could fossil fuels have been burned long before we discovered them? Could climate change have occurred once before for reasons we've misinterpreted as purely natural? In this video, we're diving into a mystery that blends geology, climate science, and existential wonder, forcing us to look at our planet and our place in its history in a completely new light. Ancient industrial civilizations. At the heart of the Silurian hypothesis lies a provocative question. Could an intelligent, technologically advanced species have once existed on Earth, long before humans evolved? This idea challenges the linear narrative of human exceptionalism, the belief that we are the first and only species to reach a high level of technological development. The hypothesis doesn't suggest time-traveling aliens or humanoid dinosaurs, but instead imagines the possibility of a civilization that may have evolved intelligence, developed industry, and perhaps even altered the climate millions of years ago only to vanish completely, with time erasing nearly all traces of their existence. The name Silurian hypothesis itself comes from a classic sci-fi reference in Doctor Who, where the Silurians are a race of intelligent reptiles that predate humanity. But in science, it serves as a metaphorical entry point into a serious line of inquiry. If a civilization had emerged during a period like the Paleocene or even earlier, hundreds of millions of years ago, it would have faced very different planetary conditions. Continents were in different places, atmospheric compositions were not the same, and most of today's landforms didn't exist yet. And yet, if such a civilization had developed industry, burning fossil fuels, releasing synthetic chemicals, mining rare elements, what kinds of signals would it have left in the geological record? This line of thinking forces us to confront the incredible brevity of humanity's own industrial age compared to the vastness of Earth's history. Modern humans have existed for around 300,000 years, but our industrial civilization is less than 300 years old. That's a blink of an eye on a geological timescale. If another civilization had arisen and fallen in, say, a span of 100,000 years, or even just a few thousand, it's entirely possible that all recognizable evidence could be gone by now. Our cities, our monuments, our machines all ground into dust and subducted beneath the Earth's crust. What remains is the possibility that we are not the first to play this dangerous game with the planet's resources, and maybe, just maybe, we won't be the last. Geological evidence limitations. One of the most striking challenges in exploring the Silurian hypothesis is the sheer impermanence of the surface of the Earth. While we often think of stone and metal as eternal, the truth is that the geological processes that shape our planet are relentless. Plate tectonics, erosion, sedimentation, volcanic activity, and deep-sea subduction are constantly renewing and reshaping the Earth's crust. Over the course of just a few million years, almost all traces of surface structures, buildings, roads, even entire cities, can be completely erased. Given that Earth is over 4.5 billion years old, and that human civilization has only existed for a tiny sliver of that time, it becomes daunting to imagine preserving evidence of a short-lived civilization from 100 million years ago or more. Fossils themselves are incredibly rare. The process of fossilization is selective and requires a unique set of conditions: quick burial, mineral-rich environments, and lack of disturbance over vast time spans. Most living organisms, including humans, leave no fossil trace at all. Now apply that same concept to something like a skyscraper or a power plant. Metal corrodes. Concrete crumbles. Plastics degrade, albeit slowly. Even under ideal preservation conditions, the chances that recognizable remnants of an industrialized society would survive tens or hundreds of millions of years are slim to none. What's more, The further back in time we look, the more distorted the record becomes. Sedimentary layers get folded, tilted, and transformed under pressure. Mountains rise and erode. Oceans open and close. Evidence of a civilization that might have existed during, say, the Cretaceous period, would be buried so deep or altered so thoroughly that we might not even recognize it as artificial in origin if we found it at all. This brings us to a deeply unsettling realization: the absence of evidence is not necessarily the evidence of absence. Our inability to detect signs of a pre-human civilization may not mean it never existed, it could simply reflect the overwhelming power of geological processes to wipe the slate clean. The Earth is not a museum, it's a recycling engine, constantly renewing itself. That fact alone makes the Silurian hypothesis more than just a fantasy. It transforms it into a serious question about the limits of what science can detect and what history might already have forgotten. Chemical and isotopic traces. If buildings, tools, and even bones are unlikely to survive the passage of deep time, then what could endure long enough to hint at a vanished civilization? This is where the Silurian hypothesis pivots from archaeology to geochemistry. Instead of searching for artifacts, scientists suggest we look for more subtle, durable signatures. Specifically, chemical and isotopic anomalies in the geological record that don't align with natural processes. These markers could act like forensic fingerprints, preserved not on the surface of the Earth, but deep within its layers of rock and sediment. One of the most telling examples comes from the modern Anthropocene, the geological age shaped by human activity. We are already leaving behind a strange legacy in the Earth's strata: spikes in carbon isotopes from fossil fuel combustion, artificial compounds like plastics and pesticides, and rare elements such as plutonium and other radionuclides from nuclear testing. Some of these materials have half-lives of tens of thousands to millions of years and are unlikely to occur without industrial intervention. If a prior civilization had similarly altered the atmosphere, oceans, or biosphere, there might be unexplained traces embedded in ancient sediments. Carbon isotope excursions, elevated levels of heavy metals like lead or mercury, or sudden, sharp warming events that can't be explained by volcanic or asteroid activity alone. Interestingly, Earth's geological past does include several such anomalies. One example is the Paleocene or Eocene thermal maximum, PETM, about 56 million years ago, when the planet experienced a sudden and intense global warming event, accompanied by massive carbon isotope shifts and ocean acidification. Mainstream science attributes this to natural releases of methane and carbon dioxide, but could an industrial civilization have been involved? The Silurian hypothesis doesn't claim this was the case, it simply asks whether we should be open to the possibility. The idea is not to rewrite the fossil record with science fiction, but to develop a clearer framework for detecting industrial activity in deep time. What counts as a red flag? What patterns of chemical change would be uniquely artificial? And crucially, how would we differentiate between industrial byproducts and those produced by volcanic eruptions, asteroid impacts, or massive natural carbon releases? In short, the Silurian hypothesis challenges us to think more like planetary detectives than traditional geologists, piecing together circumstantial clues, chemical whispers, and isotopic shadows to answer a profound question: has Earth played host to more than one technological civilization? If so, the clues may not be buried in ruins, but in the chemistry of the rocks beneath our feet. Stop. If you like this video, please give us a like, leave a comment behind, and don't forget to subscribe, since we have a new video every day. And now, let's roll back to the video. Implications for the search for extraterrestrial life. The Silurian hypothesis doesn't just raise questions about Earth's deep past, it also profoundly reshapes how we think about life in the universe. If a technological civilization could rise and fall on our own planet without leaving obvious traces, what does that mean for our efforts to detect intelligent life elsewhere? Astrobiology and the search for extraterrestrial intelligence, SETI, have long focused on finding signs of current or past civilizations like radio signals, artificial satellites, or megastructures. But what if advanced societies tend to be brief on cosmic timescales and leave behind only ambiguous geological or atmospheric footprints? This perspective encourages scientists to expand the criteria they use when searching other planets. Instead of just looking for biosignatures such as oxygen, water, or methane, we might need to consider technosignatures. Industrial pollutants, non-natural isotopic ratios, or unusual chemical patterns in a planet's atmosphere or soil that can't be explained by known natural processes. For example, if we observed a planet with elevated levels of chlorofluorocarbons, CFCs, it might suggest artificial production even if the civilization responsible had long since disappeared. The Silurian hypothesis invites a kind of cosmic humility. If Earth can host intelligent life, potentially more than once, and if those civilizations can vanish almost without a trace, then the same could be true of countless exoplanets across the galaxy. Civilizations may flare into existence and vanish like sparks, their evidence erased by time, geology, or self-destruction. From this viewpoint, the so-called Great Silence of the universe, the lack of observed intelligent life, might not be silence at all. It might be the echo of civilizations whose stories, like forgotten books, have been buried too deeply to read. In this way, the Silurian hypothesis becomes more than just a speculative look at Earth's past. It's a tool to better understand our own future, a warning about the impermanence of even the most powerful species, and a new lens through which to search the stars. It asks us not only where we are going, but whether someone, somewhere out there, might already have been. And if they were, did anyone notice before it was too late? Conclusion. The Silurian hypothesis is not about rewriting history with science fiction, but about expanding the boundaries of our imagination and our science. It forces us to confront deep, uncomfortable questions. How would we even recognize a lost civilization if it came and went millions of years ago? What traces of our own society would survive deep time? And if advanced civilizations can rise and fall without a lasting footprint, is intelligence really the permanent hallmark of a species, or just a brief flare in the darkness? By examining the geological record for subtle chemical signals, rethinking what constitutes evidence, and applying this perspective to other planets, the hypothesis bridges the gap between Earth's ancient past and our search for life beyond it. It's a reminder that our understanding of history, both human and cosmic, is still unfolding. The absence of evidence is not evidence of absence, and the silence of deep time might be hiding more stories than we dare to imagine. Ultimately, the Silurian hypothesis asks not whether ancient civilizations did exist, but whether we've even been asking the right questions. And in doing so, it transforms our search for lost worlds from fantasy into possibility.